So let's now take a look at how we can actually get a real HGM process. So we know there's a condition here that links the volatility and um, the drift in the process. So and recall that the V is actually not a volatility term for the instantaneous forward rate, but it's a volatility term for the zero coupon bond. Now, let's say we defined S, which is the volatility term for the HGM process, and let's define this to be negative minus of VT, which is dV dt, the partial derivative of the volatility of the zero coupon bond process. Now, if we look at it, then this process here that we have seen earlier using the volatility term from the zero coupon bond process will become this thing here. So this is the volatility of the process of an HGM model, under the HGM model, and this will be the drift of that process, okay? So there's a linkage between the vol and the drift, and there's also a linkage, obviously a linkage between the volatility of the HGM process with the partial derivative of the volatility of the bond process, zero coupon bond process. So we now have a model for the instantaneous forward rate. Now we look at it, it could be a multi-factor model here, right? There's no need for this to be a single one. So you can have a dzi. So the sum here and the dzi. But let's just take a look at one factor model. Now, even you have a one factor model, you notice that this is actually a process for only a single point on the curve. So the evolution of the entire curve has many of those points, right? Let's say you have n number of points on your instantaneous forward curve. And although each of the points is evolving with a single factor, the entire curve, the evolution of the entire curve is multifactored. One factor for each of the points on the curve. We can have those ones independent, so the different risk factors are independent. Okay, so and you don't really have to have a connection between the different 2 points. So each point is actually evolving independently in a way. And because you're using the instantaneous forward rate, that independent evolution of each point would not create any problem, because you can then always come back and using the term structure of instantaneous forward rate to reconstruct back the term structure of interest rate, like what we have done earlier, just move it back. So if you have a curve of instantaneous forward rate, you can then reconstruct back the curve of interest rate here, the interest rate term structure. And the independent movement of each point on the forward rate curve, instantaneous forward rate curve, is okay. It doesn't create any conflict. They can be independently moved or evolved. And any of those movements will create a sensible term structure of interest rate. Okay, so it offers so therefore you have a single factor, and it offers a very rich structure for the entire curve, and also you can recover if you want to put certain restrictions to recover the short range model. But even for this simple process here, you really have to do numerical computation in order to price derivatives that are with interest rate are implied by this the movement of this instantaneous forward rate. Now, one thing I like to point out is that when you consider a multi-factor model, the complexity is not having a lot of factors. The complexity really comes from the correlation between the factors. So then instead of a diagonal matrix, you have a matrix that have the off-diagonal terms, which means that the factor one is correlated with factor two and so on, all the way correlated with factor n. So is this correlation that makes the process very, very complex and time-consuming to resolve. Here, with the HJM model, let's say you have a single factor for each point, then along the curve itself, you actually have a multi-factor model. But the multi-factor model are all independent, so you don't have a correlation matrix between the factors. So that makes everything very simple. In comparison, if you were to have a multi-factor model for the short rate, then all those factors needs to be correlated. So, and here, if you were to have an HJM process like this, and each of them has each point is a single factor, and even if all the factors along the curves they are not correlated, but if you look at what it entails, if you derive the implied instantaneous interest rate, you will get a multi-factor model that are correlated. Each risk factor are correlated. So depending on how you express it. So let me try again. So this is actually one of the advantage of the HJM model. That's why I want to emphasize that, is that you can specify, let's say you specify a single factor for each point on the curve, and the entire curve, let's say you have n factors. But when you evolve this, everything is independent. All the different factors, the n factors along the curve, they don't have to correlate. And there's no correlation structure in this volatility structure here. And so every point is only one point. Every point when you evolve, there's only one factor. But if you, out of this entire curve, you convert that curve into a interest rate term structure, because they're connected, right? And from that interest rate term structure, you can always figure out what is the evolution of the short rate that is consistent with the evolution that we specify here. And that short rate will have multi-factor, and that multi-factor is correlated. Okay, so it's have a very complex short rate process that is implied by a relatively simple process if you define on the instantaneous forward rate. Okay.